Welcome to Ask and Learn.
Okay, let's do the first approach, that is A. Energy density is equal to half epsilon naught E square. So, net energy will be volume integral of energy density. Let's substitute the U in there. Since half epsilon naught are constant, we will have E square dV. Here, E is given by electric field of charge q, spherical charge q. So since we are outside of conductor, we can simply choose electric field E equals 1 divided by 4 pi epsilon naught q square divided by r square. Now let's substitute that. 4 pi epsilon naught square q square integral 1 divided by r square. Now we will use the spherical coordinate to integrate this question. So this will be dr times 4 pi. I am integrating over all the angles, that is theta and phi, to be 4 pi. Now limits here should be r naught to infinity, because in spherical conductor capacitor the other plate is assumed to be at the distance infinity. Now if you perform this integral, you will get u equals half, which was already there. You can see that you can cancel this 4 pi here with the 4 pi here, but it has a square, so 1 4 pi remains. Epsilon naught, one of the epsilon naught in denominator cancels with 1 in numerator, so we are left with 1 divided by 4 pi epsilon naught q square divided by r naught. Now why r naught? Because the integration is negative 1 divided by r, and limits are 0 to infinity. At infinity, the 1 divided by infinity is 0. Oh, sorry, limit is not 0, but it's r naught. It should be r naught here. So that we have the second term surviving. Since second term is negative and twice negative is positive, your answer is what you expected. Now, in the second approach, let's start with the capacitance of spherical capacitor as 4 pi epsilon naught r. And then equation 5 says u equals half q square divided by c. So if you substitute value of c here, you will get half 1 divided by 4 pi epsilon naught q square divided by r naught. I should have r naught over here. Now let's go with the third approach. Third approach asks us to find electric potential energy stored by having small charges of amount dq from infinity to the spherical conductor. Now, to do that, let's consider the work done du when you bring the charge of q. When you bring the charge of dq from infinity, and to find the work done, we need to multiply it by the potential difference of V. Now, which is dq. V here will be q divided by 4 pi epsilon naught r naught. Now, what I am assuming here is that the sphere here has a charge of q, and we are bringing the small charge dq from infinity to this sphere. But to find the net energy, all we have to do is integrate du. Now, if you integrate q dq, you will get q squared by 2. So the answer, again, you will find to be what you find in A and B. So q squared divided by 2.